In the spring, I was getting used to it being there, and one time I lecture, I put it down, and the whole thing, you just try to see me through my water bottle. Oops, forgot about that. So.
It's cutting your face.
Yeah.
That's all right. You don't see my face. All right.
There you go.
Maybe if I push it a little bit back, you guys will be all right, right? Feel hemmed in. All right, that's fine. Is that good?
Yeah.
That's good, yeah.
Cool. It's probably better if you cut my face off anyway. Okay. So any questions over what we did last time? Any other? You were saying the laws. We'll get to those properties.
Okay.
Anything else? We did order operations last time. We did fractions, stuff like that.
Mm-hmm.
All right. Okay. So we're gonna just keep on chugging. Section 1.3 is where they bring in variables. We already talked a little bit about like terms, right? And we even did a little bit of verifying something's a solution. So something like this here is -3 a solution to so how do you verify that? How do you see if that's true?
Plug it in.
You just plug it in, yeah. You could solve the equation, but it's sort of not getting at what they're asking you to do. You plug it in to check the answer, right? So where do I put the -3 exactly? Yeah, in place of the x. So if x is -3, is this statement true? That's what it's really asking.
Yeah.
Sure enough, what do you get? What do you have to do first on this side? Beautiful. You multiply before you add.
Mm-hmm.
So -12 plus 11 is
-1.
-1. Check. So is it a solution?
Yes.
Yes. Cool. Now the funny thing is sometimes I'll get a problem like this. It'll say, is 5 a solution to 3 minus x equals 8. Right, so again, you do the same thing, right?
Mm-hmm.
You check it, you plug it in for the x means I don't know what it is, but it's telling me, let's see if 5 could be what it is. So you plug a 5 in, but 3 minus 5 is? So what's the answer then?
No.
No, not no solution. Right? Sometimes people get a little confused when they solve this and you get here, you think, okay, there's no solution, but there's not no solution, it's just that didn't solve it. So the answer to this question is no. Is there a solution to this equation?
Yes.
Yes. Cool. It's just not 5. Cool. Sweet. All right, so that should be hopefully kind of nice. Normally plugging stuff in is one of the more basic things. As long as your order operations is okay, that kind of problem should be fine. In fact, we did an even uglier one last time, I think, with x's and y's and z's.
Yeah.
Yeah. Okay. So the funny thing about algebra, and the reason that is so hard, is because so many of the problems are backwards from what we're used to. But in real life, we have to work backwards. In fact, one profession that always works backwards is cops, detectives. Something has already happened. You got to work your way back to see what it leads you to, right? And the more information you get, the more you hone in on what the answer is. So we see that same thing in mathematics. If there's one thing I don't know, I really just need one piece of information, right? If I don't know what x is, but I know that x plus 1 is 2, then obviously x has to be 1. Cool. So this variable, x's, y's, and z's, they're just a placeholder. Right? I'm sure you've all heard this before, but people hate, they're like, why do you have to bring in these freaking letters in all the middle of this, 2 and times 5 is fine. Why do you need these letters? Because in real life, there are pieces of something I don't know. So I put something there so I can at least play with it. If nothing's there, how can I do something to it, right? If there's an x there, I can double it if I wanted to or whatever, right? But if there's nothing there, I can't do anything. So here, of course, we're going to get to the point where we solve equations, but that was pretty easy. What added to 1 is 2 is 1. Don't even have to do algebra on it. I just know it's 1. Okay, so variables are just numbers that I don't know yet. Right? So I say that all the time in all my classes because everything we do with variables has to act the same way as it would with numbers. Because what are variables? Numbers I don't know yet. So how much they act? Like numbers, because that's what the hell they are. Sweet. Okay, a little bit. Some of you guys are like, oh, what the hell you just said. Yeah.
Yeah. Do you on the first one that you made? Yes. Do you continue?
No, and you don't have to solve this. The fact that you got a true statement tells you that that does make this work, right? If you end up with a true statement, that made it work, so it is a solution. You end up with a false statement, that didn't make it work, so it's not a solution. That is not a solution, right? Okay. Cool. So that's the real basics of this stuff here. Blah, 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 blah. Same. Oh, here we go. Now, we're sort of stepping into the real basic building blocks of translating from English to math, right? And math is a foreign language. You all know that. Math, all these math symbols were decided upon by people who are long dead, that they all decided on it, and now we have to kind of decide to do it that way too. We just have to figure out what those mean, just like trying to learn French, right? You got to learn out what the hell "je vais à la plage" means. Anybody take French? It's the only phrase I can remember from my 3 years of high school French. I go to the beach. Je vais à la plage. So, how would I say, like, how would I translate? So now we're going to try to translate from English to Mathish. So if I have, so in English I could say the number increased by 11. So that's English.
Mm-hmm.
How do I translate that into math?
X plus.
11
I love it, because the number, I don't know what it is,
Mm-hmm.
increased by
11.
11. Right? So that's the basics. And of course, eventually that's going to lead us to everybody's most hated topic, word problems. Because the first step in word problem is just being able to do this, translate from English into math. So here's the thing, real quick. I want to kind of emphasize what I said earlier. Do you know what that is? Do we know what that is?
No.
No, of course not. But if I told you something about this, if I give you one piece of information, you could figure out the one thing you don't know. And so I'm building on that because some of you guys might have done where you have 2 letters you don't know. Then how many pieces of information do I have to give you? 2. So I have to give you 2 equations, and that's like way in our future, right? So I'm going to build on that theme. However much you don't know, you need that much information. Okay. What about, let's see, they should have, no. Beautiful. What about this? The sum of twice a number and 8. What is that in math?
X squared.
Careful now.
No.
Twice a number refers to what operation?
Multiply.
Like if I say, what's twice 10? Beautiful. Right? Multiplication, not exponents, not raising to a power. Twice 10 is 20, not 100. So the important thing to realize here is the main thing I'm doing is adding 2 things. Twice a number. So I heard the right answer several places. That's 2x and 8. Now what mistake? Can you see the mistake somebody makes if they write this down? Is that different?
Yes.
Yeah.
Definitely, right? Can you see why they might think it's that? They would key in on the fact that twice is first. Twice, a number and 8. But then that makes the multiplication the main thing. This would be the sum of a number and 8 doubled, or twice the sum of a number and 8. You guys see what I'm saying? Mm-hmm. So the sum is the main thing. Then you say of what and what, and those are the things that go around the plus sign. Maybe. So if I want somebody to write this, I have to be very specific. I have to say twice the sum of a number in 8. That's how this would, in English, this would be, what language is that? In English, this would be twice the sum of a number and 8. So look at this. The sum of a number and 8. There it is. The sum of a number and 8. And then what do I want to do with that whole thing? Double it. So that's how you'd have to say it if you meant this kind of distribution thing here, right?
Yeah.
Beautiful. You guys kind of see the difference there? Now, one of the most evil words in this kind of problem is less. It's very weird that that would be such an evil word. It is a 4-letter word, so it's got the possibility. So if I said 16 less than, let's see if I can be well, let's not be too evil. 16 less than 3 times a number. Okay, so I got one vote for 2x minus 16. 3x minus 16, yeah, 3 times, yeah. So the most common mistake is to take it the way the words are given. The most common mistake is to write 16 minus 3x. And when you do that on a word problem, that's when you start trying to tell me that the length of your shed is negative 8 feet. I'm like, what the hell kind of stuff are you making your shed out of? Is this black hole material? Are you out in space? Hey, this is good. This is some weird shit. Let's build a shed out of it. Do you guys kind of see what I'm saying? That's
Yeah.
Obviously, with a word problem, you got to make sure that it makes physical sense. When you do stuff like this, then things can become negative and get freaky, right? Okay, so this is definitely wrong. And here's the reason. What if I told you my little brother's 12? He's not really, but let's just say. My little brother's 12, and there's a kid down the street that's 6 years less than my little brother. It can't be 6 minus 12, because then the kid is 6 years away from being born, and like, I got major ESP. I sense in 6, you know. Right? So 6 less than 12. What's 6 less than 12? 12 minus 6. So it's just the built-in evilness of that word. 6 less than 12 means 12 decreased by 6. It just inherently turns itself around. So be real careful. That's where you get all your trouble with word problems. That's where you come to me and say, I don't know that. I've been working on this word for 5 hours. Oh my God, I just turned this thing around. Right? You got it backwards. Yeah. Okay. So let me give you, here, you guys try this one. And here, of course, is what math teachers do. We always let you try one that's even harder than what we did. So let me see. You guys do this one. One more than half a number is 12. Let's see if you guys can do that. We haven't even talked about is yet, but let's see if you can figure that out. Well, wait, part of it is, but not the is part. All right, so let's see. One more than half a number. So more than is like added to. So one more than half a number. I love it. Half of a number. So somebody pointed out half of something means multiply, right? Is equals 12. So do you see how it's locked? One more than half a number is 12. You can map each piece, right? That happens very often in mathematics, that it just goes straight into math from English. Yeah.
So the problem on the homework for number 30 is 3/15 of a number added to 12. Would that be like
30. Oh, there we go. 3/5 of a number added to 12. That one there. Whoa. 3/5 of a number. How would you write that? Yeah, because were you guys taught in high school that of means multiply? It strikes me that recently more and more there's been less and less students that know of means multiply. It's kind of freaky to me. It used to always be like bam, bam, everybody knew. So 3/5 of a number. So 3/5 times x. Beautiful. Added to 12. It's only going to be an equation if you see the word is, or they can even just say equals straight out, right? Otherwise, it's just going to be an expression. So can I do anything with this? Why not?
You're missing a part of the puzzle.
2 reasons. It's not an equation,
Okay.
and they're not like terms. Beautiful. I like it. So I can't simplify it, and I can't solve it. Can't simplify it, not like terms. Can't solve it. There's nothing to solve. There's no equation there. Cool.
Can you name other stuff like product, choose, multiply,
Okay.
like list it?
What are the words that mean things? So like addition could be the sum of, right?
Yeah.
So addition. What words would lead you to additions? The sum of
More than,
blah blah blah, more than,
added to,
added to.
Plus.
plus.
Okay, I like it. Plus, increased by. Right. Stuff like that. What about what leads you to subtraction?
Less than.
Beautiful, I love it. So less than,
Minus.
minus.
Difference of.
I love it. Difference between. Negative might lead you to a minus, but that's more like an opposite of a number. Might lead you to subtraction, actually. That's pretty good. Decreased by, right? Because it's just like increased by, decreased by. Stuff like that, right?
Take away.
Take away, I love it. Right? Take away,
Yeah.
sure.
That's a good one.
What about a multiplication?
Product.
I love it. So product is the main thing there. So sum is like the main thing for addition. Difference is like the main thing for subtraction. Product is the main word you'd see for multiplication. Yeah, of would mean it in those cases where you have a percentage or a fraction of something, right? So something of something. That leads to multiplication. Times. Just to go along with your minus and, right? 7 times the number added to, well, that's multiplication. Right there.
Mm-hmm.
Anything else? You know, and then words like twice obviously means multiplication, right? Twice something would mean multiplication.
What you put after the addition?
Oh, up here?
Some-
Sum of, more than, added to, plus, increased by. So those are the key words that would probably lead to addition. Keywords lead to subtraction, keywords lead to multiplication. What's the key word for division? That's that weird word that we don't see too often.
Divide.
No.
Oh, the keyword. Divided by.
It starts with a Q.
Quotient.
Quotient. Yeah.
Yeah.
So quotient, these 4, sum, difference, product, quotient. Those are the main words. The other words are things that mean those, but those are the main words that represent those operations, right? So if I said the quotient, so for example, if I said the quotient of 7 and a number, the only one that's evil is less than. All the other ones you basically do in the order they come in. Right? So the quotient of 7 and a number. Quotient means you do division, so how would you write that?
7 over
7
X.
divided by x. Cool. Right?
You can write it above that too, right?
No. Be careful. 7 over x, is that the same thing as x over 7?
No, I meant like 7 divided.
Oh, okay.
Yeah.
Yeah, you can do this. That's fine.
Okay.
Don't mean to call you out, and you were actually right. Yeah.
Sorry, because I'm going to ask Elspeth. What letter is that?
Which one?
That one. The question?
Quotient.
The
Yes.
first letter, what is
Q. Yeah.
it? Q.
Yeah, my Q's are just something else. It's not going to make it any better. There. Everybody thinks it's trying to be an E because they don't ever connect this. Well, that's just a quirk of mine, sorry. Quirk spelled with a weird Q. All right.
I have a question. In the first problem, does it matter if 1x is on the other side of the 1? 1x plus 1?
Oh, you could put 1/2 x plus 1.
Yeah, 1/2.
Definitely. Yeah. Cool. In fact, in general, if I said one more than a number, I always do like this. Because then one less than a number, I'll be less likely to forget that's actually got to be this. Right? One added to a number is one more than a number. One taken away from a number is one less than a number. Right? So it's another way to kind of remember, to force yourself to remember that less than turns them around. Do it for more than also. Whatever works. Okay. So is that cool? Is that right? All right. So that's basically what we're going to run into so far. Where'd it go? Okay, that's right. Cool. Now, let me say a couple of words and see what you guys think here. If I say the word set, tennis players out there think of one thing. That's me included, so I don't mean that. A set of numbers or a set of objects. How do we do that in mathematics? If I want to say the set of even numbers between 0 and 11. What are those?
0, 2, 4, 6, 8, 2.
0 itself is not really either one. Yeah, so you'd say 2, 4, 6, 8, 10. And so these brackets tell you that you've created a set of numbers. So this is when you want to make a list of numbers. How many of you have ever heard of something called interval notation? Okay, so that's going to be when I want to have like every single number between 0 and 11. And I mean like 0.000749, 0.000750, 0.000751. That would be interval notation. So thank God I don't have to list them all out. We'll have a much quicker way to say it. But if there's only a few numbers, let me just list it out. Put it in set notation, right? So there are certain types of numbers that we've given special names to. This set, let me try to write it. 1, 2, 3. We call these a couple different things. We call these the natural numbers or the counting numbers. Has anybody ever heard natural numbers?
Yes.
So these, of course, I like to kind of tell a story when I talk about this. Like back in the days of cavemen, right? I'm walking around, I pick up a couple rocks, I'm happy. I have 2 rocks, and these are what come naturally to me. 1, 2, I can see them, right? In fact, do you guys realize that 0 had to be invented? The idea of 0, there were whole civilizations that had no concept of how to write 0. They didn't realize they needed it. The Babylonians created 0 right before the civilization fell. So they're all like, hey, look at that, it's amazing. Oh, crap. We're all dead. It's too bad for them. But this is what came naturally to us. 1 thing, 2 things, 3 things, right? We can't imagine 0 being freaky because you've been born and brought up with knowing 0. But it had to be come up with. So when they came up with it, they added it in. And what does 0 look like? It looks like a hole, right? So these are the whole numbers. So the whole numbers go 0, 1, 2, 3. Are you guys cool with me putting those little dots there, right?
Yeah.
It just means continue in the same fashion. So obviously 7.8 is not in here because it doesn't follow that pattern. Just all the whole positive whole numbers there, right? Positive, not including 0. So 0 adds it, and that's the whole numbers. So this would be like I got my 2 rocks, and I'm happy, and all of a sudden a dinosaur jumps out at me, and of course I love that whole thing about dinosaurs being with. I'm thinking about cartoon evolution here, by the way. So a dinosaur jumps out at me, and I lose my rocks. So now I got 0 rocks, right? Yeah.
Yes. What do you mean a natural or?
Yeah, it's just they're called. I call it natural numbers normally, but I've seen it counting numbers also. I don't know. Yeah, they call it both in this book. It's just 2 different names for the same thing.
So
Yeah.
what is the word
I'll normally say natural numbers because that's what I'm used to saying.
What's the next one?
Whole numbers.
No, no,
Yeah.
no, no. Bottom.
Natural or counting.
Counting.
Yeah. Cool.
The only difference between natural and whole is 0.
Exactly. I like it. And the reason that this becomes important is because later in mathematics you might want to say you're only allowed to use natural numbers. Because maybe, like here, where did I just do that one? We had one like this earlier. Could you use every whole number in that? Think about it. Could you put every whole number in for x? Which whole number would not work? If you try to plug a 0 for x, can you do that? Can you do 7 divided by 0? No. So you might want to tell people you can only use natural numbers. Because 0 will freak it out, right? Or you know, and maybe I don't want to have a fraction down there. You see what I'm saying? I want to be able to say really quickly what people can use. Right? A real quick word about this. What do you guys call this when this happens? Undefined. Cool. And you would say that, so this is undefined. Do you guys know why you call it undefined?
Because it's
Here's why. You ready? You ready?
Start.
And this is what is 6 divided by 3?
2.
Now, let me be careful now. Why? Don't say because 3 goes into 6 twice. Be more specific. Because 3 times 2 is 6. So 2 is the number that is defined to be the number that I multiply by 3 to get 6. So 7 divided by 0, I'd have to put a number here that when I multiply it by 0, I would get 7. Is there any number defined to do that?
No.
So we call it undefined. So never just take it at face value. You should go, what the hell do you call it undefined? Because there's no number defined to do what it would have to do. Cool. Some of you guys might have ever called that infinite. And we'll look at that, and that actually makes more sense once we get to everybody's second least favorite topic, graphing. Right? When we talk about infinite slope. Yay. Okay. So a little side note there about that. So now here we go. I had 2 rocks. I lost both of them. So now I have 0. So I had to come up with the idea of 0. I had to invent it. So normally in real life, if I have no money and I need to get something, I go and borrow some money. Which requires what kind of numbers have to be created now to designate that I'm in debt?
Negative.
Negative numbers. So if I go borrow a rock from Krug, who lives in the cave next door, I got to come up with the idea of negatives to show my balance in the rock bank. I don't know what the hell. It's too far with the story. So I'm going to add in all the negative numbers, all the negative whole numbers. Oops. It keeps going in both directions. Do you see that? It goes anywhere from negative infinity, negative 18 billion, negative 40, negative 3, negative 2, negative 1, 0, 1, 2, 3, 80, 100 million, 600 trillion, blah, blah, blah. You know, forever in both directions. Cool? Okay. What kind of numbers have we left out so far?
Fractions.
Exactly. So I'm happy I got my little borrowed rock. I'm just happy to have a rock. I don't know. And then I trip again because I'm a clumsy dude, and it breaks in half. So that I need to create the idea of fractions, right? And what we call, anybody know the name of it officially? The name of everything that would be written as a fraction? Like we got natural numbers, whole numbers, integers. What kind of numbers? No?
Real?
Imagine.
Real is too far. What is a fraction anyway? It's a
Part.
what of 2 numbers?
It's a part of a pie slice.
Ratio of 2 numbers.
Ratio. Yeah.
So the next level would be rational numbers. So rational numbers are everything that could be written as a fraction. I can't write that like this. There's no pattern I could set up that would catch every possible fraction. So I have to write it as a definition instead. Anything that can be written as a fraction. So for example, obviously, let's say 7/8. That is a fraction, so it's rational. What about the number 3? Can you write that as a fraction?
Yes.
You could put it over
1.
There you go, see? So every single one of these, every natural number, every whole number, every integer are rational because you can just put them over 1. Or if you want to make it more interesting, you can make it 6 over 2. That's 3, right? If you can write it as a fraction, it is a rational number. Fractions officially are ratios of whole numbers, right? Where the bottom is not 0, obviously. So you can't make it 1.7 over 3. That's a fraction. No, it's not. It's got a decimal in it. What about, here's something that might be a little freaky. What, Jeff? I don't know. 0.1111 forever is a rational number. Before you get there, real quick, obviously something like this is rational. What would that be as a fraction? 104 over what? What place is that in? We'll get back to that. That means repeating, right? 104 out of what now? Tenths, hundreds, thousands. I love it, right? So any decimal that stops is automatically rational. You just have more and more zeros on the bottom. You with me? If it stopped further out, the bottom would have been a bigger number, but it would have still been a fraction. Yeah?
Is all the natural numbers considered rational numbers?
Exactly, because every natural number you can put over 1. Real quick word. See how they keep building? Every one of these is in here. Every one of these is in here. Every one of these is in there. Right? They keep building on each other until you get to the trash pile, the freaky ass numbers. Like pi stuff. That's the next level. This guy is kind of nifty. This guy is actually 1/9. So if you did that on your calculator, 1 divided by 9, sure enough you get 0.11 forever. Who in here knows what 1/3 is? Normally some people know that. 1/3 is a decimal. Forever, right?
Yeah.
Real quick. You might not like this, but if you say 1/3 is 0.333 forever, isn't 1/3 the same thing as 3/9? I haven't done anything freaky there, right? 1/3 is 3/9. Multiply top and bottom by 3. So you're saying that's true, right? If I divide both sides by 3, don't I get 1/9 equals 0.111? So what's 2/9? Come on, you can do it. 1/9 is 0.111. 3/9 is 0.333. 2/9 is 0.222. 7/9 is 0.777. Cool?
Oh, okay.
Most decimals that have a pattern are over 9 or 99 or 33, some multiple of 9 or 3 or something like that. That if I take something, if you divide 27 by 99, you'll get by, maybe it's 0.272727, I think it is. Yeah.
So the infinite ones is a rational number?
Is a rational number. Why? Because it can be written as a fraction. Because 0.111 forever is 1/9, it is rational. So what do you think the last set of numbers is called? Oh, sorry.
I got a question about
Yeah,
that.
yeah.
If you add a whole number in front of it, so if you say it's like 2.111?
Yeah, then it would just be 2 and 1/9.
Okay.
Yeah, so that's a good point. If I put 2.111 forever, that would be 2 and 1/9. Cool, I like it. Sweet. So whole number pieces really don't give us that much trouble until we start trying to bring them into the fraction, right? The fifth piece here, the second to last piece here, is called the irrational, meaning the not rational. So these are not numbers that you can't reason with. These are things that don't follow this rule. And there are very few of them that we know right now. Like I said earlier, pi. What is pi?
3.147,
No.
whatever.
Yeah. And they always have these contests where people memorize 50,000 places of pi. I'm like, good God. I got better uses for what little brain cells I have left unoccupied. Thank you. But pi actually came from, if you take any circle and measure how long around it is, circumference, how far across the middle it is, any size circle you do that with, it will always come out to the same number. And that's why we gave it that symbol. So all these civilizations, the Egyptians had their own, I think theirs was 22 divided by 7. So if you do 22 divided by 7, you get like 3.15 or whatever. They got pretty close, right? But civilizations, their mathematicians noticed this. No matter how big your circle is, how small your circle is, if you measure all the way around and across and you divide those, you always get the same damn number. So they thought, must be from God, right? So that if it's some holy thing, they had to give it its own symbol. And you see this all the time in math. You see the Egyptian pyramids. I don't know if any of you heard this. They were built in such a way that the ratios always came out to this magic number, and everybody thought that must have meant the Egyptians were more advanced. And I don't know if it's true or not. Who knows? But there's all these special numbers that come up, and that kind of tells us, oh, maybe that civilization knew a lot of math, or they were just lucky. I don't know. Anyway, so it could be pi. Why would it be pi? Because pi doesn't have a pattern like this. It's 3.1415, blah, 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 and it doesn't, there's never any time that it starts repeating, and there's no pattern to it. It never stops like this one did, and it doesn't have a pattern like this one does. So it can't be written as a fraction. Also, any square root that we can't do. Square root of 2 is 1.414, blah, 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 no pattern, never stops. Right? Okay. How are we doing so far?
Good.
So I think of this as my trash pile here, right? So here I was as a caveman. I dropped my rock, had to come up with the idea of fractions. And this is a weird cave dude off on the rock by himself doing some weird ass shit. Leave him alone. Don't talk to him. And these are all of these are real numbers. Every single one of these. Every number we look at in this course is going to be a real number. Next semester, or the next time you take math, you'll be talking about stuff, complex numbers, made up of imaginary parts, which was where students go, I knew it! Making all this shit up. But it's just an unfortunate choice of word, really. All right. So that's a little review. That should be familiar, hopefully, a little bit. Okay. Let's see, blah, blah, blah. Okay, cool. Blah. So if I said draw a number line, everybody draw a number line. See if anybody not sure what that means. I didn't say it, so it could be in it. What should be probably be in the middle? It doesn't have to be, but you can put 0 in the middle. Especially if I'm not talking about any specifics. So -1, 1, 2, 2. So real numbers, another definition of real numbers is any number that can be found on the number line. So I know I put a special point where 0, 1, and 2 are. I show myself where all the integers are. But isn't there also fractions on there?
Yes.
And there actually square root of 2 is in here somewhere. There's square root of 2 right there. It's on there, right? So any real number has to be able to found on this. That's why we call this a real number line. How do you draw this statement here? How do you show this on this number line? Might be getting ahead of myself, but it's too bad for me. Do you guys know how to do that?
Circle the 2, and then go
Good.
towards the negatives.
And go this way. Cool? Again, I might have gotten a little ahead of myself, but if I wanted to draw on a number line x equals 2, that would just be, put a dot here, right?
Yeah.
Now, if I want it to be less than 2, is 2 a part of that solution? Is 2 smaller than 2?
No.
That would be weird if it was. You have to be 2 years old. I am 2 years old. Oh, that's too bad. You can't come in. 2 is less than 2. What? Wait a minute. So 2 works. What else? What other numbers are less than that?
1.
Every single number that's below there, right?
Yeah.
The really cool thing is which direction does that look like it's pointing?
The negative.
The way that I shave.
Yeah.
That's awesome. And some of you guys know alligator and all that kind of business, right?
Yeah.
I always think about the fact that this looks like a lazy L. Doesn't it look like an L? That's not. It's just kind of like. Right? So I remember that's less than, because it looks like an L. The other one must be greater than. It doesn't look like an L. If you want a way to remember these symbols, right? Yeah.
So, like, you would shade in the area that it's pointing to?
Exactly.
So
As long as the variable's on this side, this points you in the direction of shade. That kicks so much ass. That's what people get in trouble when they see this and then they draw this 3 and they draw this. That's wrong.
I would guess.
Because the x is not on the right side. If 3 is less than x, x is negative. If 3 is smaller than x, x is bigger than 3. So I should have went the other way. See, it points me in the right direction if the variable is on that side. It's an awesome thing to know.
Variable has to be on the left side.
Exactly. Cool. Okay, maybe. What does this symbol here mean? Like, I think we already talked about this the other day. Is that true?
Yes.
We did talk about it the other day, right?
Yes.
Because of the fact that this allows it to be
Equal
to. I like it. Cool. Okay. Ah, cool. Here we go. Now. Time to go. Okay. What does this do to something?
Smooth value. Makes your head spin. Oh.
Okay. And what's this? Careful. 4. It's the most single-minded function anywhere. We've already got a function that changes the sign. Just put a negative in front, right? I don't need a function that changes the sign. This is a function that always comes out positive or 0. The absolute value of 0 is 0. And 0 is neither negative or positive, so it's a little tricky. Why does it always come out positive? Does anybody know what it's based on? Absolute value always comes out positive. I have a T-shirt that says this. I don't wear it here too much because I don't know if my deans would like that. What is the absolute value based on? What idea? Does anybody know? Tell me this. I'm going to give it away. Are either one of those further away from 0?
No.
They're both how far from 0?
4.
If somebody came up to you and said, "Hey man, there's like a whole pile of money. It's about negative 80 feet down the street," would you look at them like, "Are you the guy making that weird shed?" Right? Distance can't be negative. Just because you're standing behind me doesn't mean you're negative feet away from me. That's freaky. Right? Where are you? So, absolute value is based on distance. That's why it always comes out positive. Distance from 0 in this case. So negative 4 is 4 away from 0. 4 is 4 away from 0. 0 is 0 away from itself. Right? The mistake people make is something like this here. I always see this. This is a mistake. Big time mistake. What do you think order operations would tell you somebody did wrong here? What are you supposed to do first?
Add the set.
What do you think absolute values are like in the order operations? What place should they come in?
Exponent.
What do they look like?
Oh.
Parentheses, right? So don't you do the inside first?
Yeah.
In fact, I can't do the absolute value of a number until I know what the hell the number is. See, I get 9 here, but what is 2 minus 7? Negative 5, so what should it be?
5.
So how the hell would you get 9? So you can't do the absolute value of a piece of a number. You have to know what the hell the number is first. It's just good old order operations saving your ass. So absolute value signs are just like parentheses as far as order operations, right? You do inside them first. Okay, cool. So the only way, people get a little confused about this, but what would this be?
Oh, you solve the inside first.
Yeah.
Order operations saves your ass, right?
Minus 11.
So what do you do first?
7.
The inside.
7.
Can these two negatives cancel?
No.
Why not?
Oh, because that's your solve.
Because you have to do the absolute values now, right? Negative what? I don't know yet. Negative, what's the absolute value of negative 7?
7.
So there's the answer. So people get a little confused. They're like, well, why'd you get a negative answer when you got an absolute value? Because I got a negative symbol in front of the damn thing, right? That is positive with a negative sign on the front. That is 7. Absolute value's got to be positive, but they put a negative sign in the front. So I end up with negative 7. Order operations still saving you from yourself, right? Okay.
Wait, why is it negative 7 again?
So the really cool way to look at this kind of problem is cover that. Do that problem now, right? So 4 minus 11 is negative 7. The absolute value of negative 7 is 7. What's on the outside of the problem, though? A minus sign. There you go. So it's the opposite of what you would normally get here. So normally I'd get 7 there. The opposite is negative 7. Okay. Cool, cool, cool. My favorite phrase is, that makes sense.
So you keep the negative.
You have to, because it's exactly the same as, what's the last thing you would do here? What's the last thing you would do?
Multiply.
Multiply. So it's not, I'm saying the same thing. What's the last thing you would do here? Isn't there understood 1 there? The last thing you would do is multiply that negative. That's exactly what we did, right? Figured this piece out, multiply by negative. Same thing as that. Order operations. Now here's the freakiest part about absolute values. Here's, and I'm not going to dwell too much on this. It's not going to become really important until later. That is really hard to do. Believe it or not. I always get people telling me it's this. That's not true. Think about it. What could x itself be?
Something, anything.
It could be 3, in which case that's fine, right? If x is 3, then the absolute value of 3
It's 3.
is 3. But what if x is negative 3? Then this says the absolute value of negative 3 is negative 3. Is that true?
No.
You guys see how that says that? Do you see how that says that?
Yes.
The grammar was good. The absolute value, I replace x with negative 3. That's no good. So that can't be true. The reason this is a really difficult thing to do is because what is on the inside? What kind of number? I don't know. And doesn't the absolute value do 2 different things? If it's positive already, what does the absolute value do? Nothing.
Yeah.
If it's negative, what does the absolute value do? Changes the sign. See, so it does 2 different things. So watch this. Let me see if you guys. If the x is positive or 0, is that all right? If it's not less than 0, it'll leave it alone. So like if x is 3, the answer is 3. If x is 12.8, the answer is 12.8. Right? If x is negative, less than 0, it's got to change a sign. How do you show me that in math? To change a sign of something.
It's going to go this way.
Careful now, not the inequality or something, but the actual positive, negative.
I don't know what you're
So if I have the number negative 4, what can you do to that to make it become 4?
Well, add a negative
Multiply by a
Oh.
negative.
Yeah.
So if I have x is negative 8, I have to make it positive. What do I do?
That's negative 1.
That. So let's check it out. Let's check it out. So if x is negative 8, what is this saying then? It says the absolute value of negative 8 equals negative 8. And what is negative 8? 8. So putting a negative in front of something, don't we already know that changes the sign? So doesn't it make sense it's going to show up in doing absolute values? Because what do absolute values do sometimes? Change the sign. They only change the sign if it's negative. They leave it alone if it's positive. I said a lot more on that than I wanted to. That's going to become really more important when we get absolute value equations. Right now that looks freaky because this freaks people out. They're like, you can't have an equal a negative number. I don't. If x is negative, what's negative times x? Positive, right? Negative times a negative number is positive. But our brain says, no, it's a negative. Right? But don't, that's enough of that. We'll get more into that later. I'm desperately trying to get through chapter 1. Please definitely slow me down if I'm going over something freaky. That piece is not going to become important until later. Oh. A real quick word, I think I told you this earlier. If you have any trouble with this kind of problem, and I know some of us have some trouble with this. I used to teach it like digging a hole in the sand or climbing up a ladder. And that got really complicated, I think. Like this would be, if you're up 7 feet on a ladder and then you fall 9 feet down, you must be 2 feet in a hole or something freaky. Right? That gets a little weird. It's good to have a visual. A better thing is money. If you got $7 and you got to pay somebody off $9, you're $2 in the hole, right? So you're down 2. Even more direct than that, though, is this simple rule. It's only 2 pieces. If they're different signs, you guys see? That's a positive 7. It's a negative 9. Subtract them. What's 9 minus 7?
2.
And then put the sign of the bigger one back on. That always works. So if I have negative 8 plus 13, different signs. So what's 13 minus 8?
5.
What's the bigger one?
13.
Positive, so it's positive, right? If they're the same sign, you add them and put the sign back on. So if I had negative 11 minus 12, same sign. 11 and 12 is 23. Put the sign back on. Yeah. I think those are the most direct rules to remember. Different sign, subtract, sign of the bigger one. Same sign, add, put the sign back on.
When you multiply, they turn positive.
Exactly. Because what does a negative mean? A negative means the opposite of 11, right? And the opposite of 12. So when I do this, what's the opposite of? The opposite of 11.
11.
11. To me, that's the most direct way to think about why 2 negatives cancel when you multiply. They sure as all hell don't cancel when you add. I wish they did. Because then I got, okay, negative $11 in that account, negative 12 in that account, 2 negatives cancel, I got $23. I'm going to go buy some stuff. I don't think my bank's going to agree with me, right? But I'm not trying, hopefully you see what I'm doing. Good. So it's multi. It's that students I hear all the time. What? Math sucks. You're always doing something different here. Well, that's because this is different. It's a different operation. So of course it might do differently. Opposite of opposite cancels. But if I have a negative and another negative, I'm still negative. Right? I'm down. Oh, this guy 11. Oh, this guy 12. I owe overall $23. I'm still negative. I can't get rid of that negative that way. Unfortunately, I can't multiply my bank account by a negative number either. So. Yes, I have just multiplied my bank account by negative. No? Okay. Shit. All right. All right, that's good. Good. So let me see how much time. Oh, good. One quick little problem here. You guys try this. Let's do that. This one. Let's try and be a 15 here, right? All right. Okay. Okay.
Perfect.
Yeah.
No, I'm just saying, I'm guessing, is it 1? Is the answer 1?
Could be 1.
I got 5.
It's 1.
Could be 1.
6.
I don't know. 6. All right. Let's see what we get. What's the very first thing you should do?
Parentheses.
So,
Yeah, these things that look like parentheses. So
that'd be negative 8.
Multiply.
And then for 5 and 2.
2 times
what's the very next thing you have to do?
change the
It's
absolute.
not multiply.
Change the
No,
absolute.
change the
Absolute
8.
value negative 8 is
8.
8.
You got 2 times 8. You got to do that first. 6.
Now, did anybody? Hopefully, nobody made a plus sign show up there.
Yep, I did
Be
that.
careful. Multiplication cannot become addition. This is 5 minus twice this. And what is this? 8. So it better still say 5 minus twice this. You're just replacing this with what it is. Don't make it become addition. Be real careful about putting a plus when you know it becomes